In the previous video, we talked about how we can use commits as save points, which we can use to restore our code to previous states if we decide that the code that we've created since isn't worth keeping. And it's also useful for keeping track of what's going on in our project in terms of progress. If your project begins to grow, it's likely that multiple people will want to work on the project at the same time. Under normal working conditions, this can be very confusing because multiple people editing the same files is not going to work out well for anyone. For example, the code is almost never going to be in a state where you can actually go ahead and test it. To solve this problem, Git and other versioning systems actually have support for what are called branches. If we consider commits to be similar to creating a zip file to save progress, we can think of branches as creating new folders, and each of those folders containing different copies of the entire project, which then allows individual people to work in a folder of their own and not conflict with the changes that other people are making on the project. Because now all of the files which are associated with the codes that they're working on are in a folder of their own, separate from the main project. In GitHub, by default, there is a master branch. This is the main branch of the code, or the main folder. And we'll talk about what different branches are used for later on. If after creating this README file, one of our friends came along and says that they wanted to help work on this project, we could go ahead and create a new branch. So for example, we can create a branch called test code, which again is going to need to be a single word, no spaces. And this is going to create a new branch for us. And as you can see, this has changed from master to test code at the top. By switching to this new branch, we've automatically changed the contents of this folder to correspond to this new test code branch. So we could, for example, go ahead and make changes to the README file and save that, which will show up in GitHub as uncommitted changes. We can then go ahead and save these changes into our new test code branch. And these changes have obviously been saved. We can, however, still revert back to our master branch, which is our main branch, and we don't have this change in this version. If we open up the folder again now, we can see that this is reverted back to the original file. So these are almost independent folders. So just by switching between the two, we can change the contents of the files. In a real project, these changes would be different methods, different classes being created, different files, etc, etc. But for the purpose of this demonstration, we're obviously just changing these two lines. There are a couple of informal rules that you should consider following when you're using branches, which we'll go through now. The first of which is the fact that each branch that you create should be based around additional functionality being added, and not necessarily on the person who's working on it. So for example, if you were creating a website and you wanted to create a new navigation pane, you would create a new branch called nav pane or something similar. And everything related to that new feature or that change would be included in that branch. This means that ultimately different people can come along and work on that branch over the course of its development cycle. Whereas if branches are named after individual people, they become a lot less focused, and there can be changes not associated with that main functionality included in the actual branch creation. Another informal rule to follow, which has a lot of benefits, is the rule that every single commit should be in working condition. You shouldn't save the state of your project while you're midway through the creation of a piece of functionality, because that means that whoever's next to pick up that piece of functionality has to figure out exactly where you were up to. Whereas if it's entire pieces of functionality which are committed, it's much easier to pick up other people's code. There is some other what's probably best described as best practice within the development community with regards how you use Git branches. For example, different meanings are given to different types of branches. The master branch is often considered the release code. So every time you made a release in your project, for example version 1, version 2, there should be a new entry in the master branch. As soon as the project is created, a second development branch should typically be created. Every time some code is added into this branch, it's considered a new alpha build or a beta build, depending on how you're actually going about working on your project. The development branch contains code which may not necessarily be 100% tested, but should work as far as possible, without crashing the actual program itself. From the development branch, we often create functional branches. This is where new functionality is created and then added into the development branch. So as I mentioned earlier about the navigation example, if we wanted to create a new navigation system, we would already have a separate master and development branch, and from the development branch we would create a new branch called navigation. Once a piece of functionality is completed, so in this thought example, the navigation system is completed, that branch obviously then needs to be merged into the branch above it. So our navigation system would be merged into the development branch. This then gives us an opportunity to test out how it's actually operating, and if we have different pieces of functionality being developed at the same time, this gives us an opportunity to actually consider how they're actually working together before we actually release it into the master branch. If you're going to conduct user acceptance testing, for example, this is often performed on the development branch before that development branch is merged into the master branch. As we've mentioned, the commits become more important within a branching system. And if we consider a branch to be an entire piece of functionality, for example a navigation system, each commit should be focused on how that navigation system is constructed. So in a navigation system, you may want to first find out all of the possible navigation options, which will be a commit in itself once that functionality is in place. You may then want to take that information and construct some elements to display that information to the user, which will be a separate commit. Once you've created those elements, you may want to go ahead and align them and lay them out in a specific way, which will be a separate commit again. And then only when you are happy that all of the functionality is complete, would you go ahead and merge that into the development branch. In terms of a realistic example, if we wanted to have multiple people working on the project at the same time, while one person is working on a navigation system, we could have another person working on images, or database connectivity, or the core of the framework itself. Each of these would be branches of their own. So we've talked about how we can create new branches and what actually goes into them, but what happens when we're finished with the branch? Well, as we've alluded to, we need to move that code back into the main branch, or the branch immediately above it, whether that's the development branch or the master branch or whatever else. And we do this by merging branches. Within the GitHub tool itself, we actually have the ability to do this quite easily. So if we navigate to manage, which was simply by clicking manage from the branches drop down, we can see an overview of the current branches. So we're currently in the test code branch, and we also have the branch called master available to us. And all we need to do is drag the master branch into the second one, and the test branch into the first element at the bottom. And this will merge the test code branch into the master code branch, as you can see here. If we click commit, that will go ahead and merge those into one another. If we go back across to the main screen of the GitHub Windows client and switch across to our master branch now, we can see that this commit has already been added in here for us. And indeed, if we open the file up again, we'll see that some changes here has been added. This means that we also now have this unused test code branch. So once we've selected the master branch, we can go back into manage, and we can go ahead and delete this branch. It's a good idea to delete old branches because it will reduce confusion in the long term, and there are no limits about how many branches you can create. So as you can see, because we had merged that into our main branch, there was no warning message about deleting that branch. It's gone and we can't get it back. And if you look here, the test codes branch has been deleted from here as well. And this is because branches in and of themselves aren't actually very useful in terms of managing the project. They're only useful in allowing multiple people to work on the project at the same time. And so once their use has been fulfilled, there's no problem deleting them, because we already have all of the commits in our master branch. In the next video, we're going to have a look at the commit history in a lot more detail. At the moment, we've only really gone through the fact that we have a history, but there is a lot more that we can do with it, which we will take a closer look at. So make sure you subscribe so you don't miss it.